So everything that we did in this section so far was to secure our application and our users' data as good as possible. And I talked about a lot of things we can do to achieve that. But all of this information was kind of spread out all over these lectures. So I decided to create this quick summary with many best practices that we already implemented and that we're still going to implement in the rest of the section. Because security is so extremely important, but unfortunately, many courses don't address it enough. Now, I'm also not turning this Node.js course into a security course. There are better courses and experts for that. But I will show you a couple of things that you can do to properly secure your applications and data. And I'm going to look at a couple of common attacks and give some suggestions to prevent them. And first up, we have the event of a compromised database, meaning that an attacker gained access to our database. Of course, this is an extremely severe problem, but to prevent even bigger problems, we must always encrypt passwords and password reset tokens, just like we did in the videos in this section. This way, the attacker can't at least steal our users' passwords and also can't reset them. Now, about actually preventing attacks, let's talk about the brute force attack, where the attacker basically tries to guess a password by trying millions and millions of random passwords until they find the right one. And what we can do is to make the login request really slow. And the bcrypt package that we're using actually does just that. Another strategy is to implement rate limiting, which limits the number of requests coming from one single IP. And this one we're going to implement in one of the next videos. Also, a nice strategy is to actually implement a maximum number of login attempts for each user. For example, we could make it so that after 10 failed attempts, the user would have to wait 1 hour until he can try again. Now, I'm not going to implement this functionality in this section, but please feel free to experiment with it on your own. It's probably a really cool learning experience to code this up by yourself, and it's actually not that hard. Alright? Next up, there is the cross-site scripting attack, where the attacker tries to inject scripts into our page to run his malicious code. On the client side, this is especially dangerous because it allows the attacker to read the local storage, which is the reason why we should never ever store the JSON Web Token in local storage. Instead, it should be stored in an HTTP-only cookie. That makes it so that the browser can only receive and send the cookie, but cannot access or modify it in any way. And so that then makes it impossible for any attacker to steal the JSON Web Token that is stored in the cookie. Again, we're implementing this in a second. Now, on the backend side, in order to prevent XSS attacks, we should sanitize user input data and set some special HTTP headers, which make these attacks a bit more difficult to happen. And Express doesn't come with these best practices out of the box, so we're going to use middleware to set all of these special headers. Next, we have denial of service attacks, and maybe you've heard of these. It happens when the attacker sends so many requests to a server that it breaks down and the application becomes unavailable. Again, implementing rate limiting is a good solution for this. Also, we should limit the amount of data that can be sent in a body in a post or a patch request. And also, we should avoid using so-called evil regular expressions in our code. And these are just regular expressions that take an exponential time to run for non-matching inputs, and they can be exploited to bring our entire application down. Okay, next up we have the NoSQL query injection attack. And query injection happens when an attacker, instead of inputting valid data, injects some query in order to create query expressions that are going to translate to true, for example, to be logged in even without providing a valid username or password. It's a bit complex, and you should definitely Google it to learn more. But what you need to know is that using Mongoose is actually a pretty good strategy for preventing this kind of attacks, because a good schema forces each value to have a well-defined data type, which then effectively makes this type of attack very difficult to execute. However, it's always a good idea to still sanitize input data just to be sure. And we will take care of that a bit later. Alright, and now to finish, I just have a couple of best practices and suggestions on how to improve the authentication and authorization mechanisms that we implemented. So the first thing I need to repeat over and over and over again is that in a production application, all communication between server and client needs to happen over HTTPS. Otherwise, anyone can listen into the conversation and steal our JSON web token. Next, always create random password tokens, not generated from dates or something like that, because they are effectively passwords, and so they should be treated as such. Plus, always give them expiry dates, just like we implemented it, alright? And we also implemented that a certain JSON web token is no longer valid after the user has changed his password. So we basically revoke the token as soon as the user changes the password, which makes a lot of sense, but again, many tutorials out there simply do not do that. Another big thing is to never ever commit a configuration file, like for our environment variables, to a version control like Git. In fact, do not upload it anywhere, because this file contains the most sensitive data of the entire application. For example, if someone gets access to your JSON web token secret, then your entire authentication process is compromised. Okay, and now just a small detail is to, whenever there is an error, to not send the entire error to the client. So stuff like the stack trace could give the attacker some valuable insights into your system. And so of course, we don't want that. Next up, we can use the CSRF package to fight a type of attack called cross-site request forgery, which is an attack that forces a user to execute unwanted actions on a web application in which they're currently logged in. We're not going to do that in this section though, but I still wanted to mention it here. Next, we could require the user to re-authenticate before performing a high-value action, for example, making a payment or deleting something. Again, this is just a suggestion that you can try out for yourself. Another cool feature that you can implement is a blacklist of untrusted tokens. So we already know that there is not really a way to log users out of the application if they show some malicious activity. But what we can do is to create a list of untrusted tokens that are then validated on each request. And next up, a feature that we could have implemented is to confirm the email address after an account is first created. So basically by sending a link to the user's email, like many real apps actually do. But I wanted to just keep things simple here, which is why I didn't do this here. But please feel free to just implement this yourself if you feel like it. Now, a big feature that many apps have is the concept of refresh tokens, which are basically to remember users, so to keep them logged in forever or until they choose to log out. Our current implementation makes it so that the user has to basically log in again after the JSON web token expires. But with refresh tokens, that's no longer necessary. And it's a bit complex to implement, and so it's a feature for another time. And finally, the last one that we could have implemented is two-factor authentication, which I'm sure you're familiar with. Basically, with two-factor authentication, after logging into the application, the user needs to perform a second action to really get authenticated. And typically, that is to insert a code sent via text message to a mobile phone. So these are a lot of functionalities our authentication could have, and if you want me to implement any of them, please let me know so in the Q&A section. And if there is a lot of demand for one of them, then I will show you how it works. Okay? But again, I didn't want to turn this Node.js course into a whole security and authentication course. And just to finish, something that we will implement in the rest of the section is to prevent parameter pollution. For example, try to just insert two field parameters into the query string that searches for all tours. And if you do that, you will find that there will be an error, because our application is not prepared for that. And so attackers try to use these kind of weaknesses to crash applications, which is of course not good. And so we need to fix that. Okay, so this turned out to be a lot longer than I expected. And there are entire courses about security if you're really into security. Alright, but I am leaving it at this, and so let's now move on right to the next one.